Beneath the thin atmosphere of Mars lies an enigma, a desert landscape shaped by flowing water. In the distant past, Mars must have had a warmer, wetter climate. But scientists wonder, just how wet was ancient Mars?
So in the ancient past, we have some indications that water was flowing on the surface, but how much water was there? We're talking about oceans, are we talking about small rivers, little rain? So these definitions of how much water was on the planet was very undefined.
A major question has been, how much water did Mars actually have when it was young, and how did it lose that water?
To answer this question, a team of researchers at NASA's Goddard Space Flight Center used infrared telescopes on Earth to study water molecules in the Martian atmosphere.
We used the world's 3 major telescopes for infrared astronomy. From the ground, we could actually take a snapshot of the whole hemisphere of the planet on a single night.
The new infrared maps reveal the atmospheric ratio of normal to heavy water molecules at different locations and seasons on Mars. Heavy water molecules contain a heavy isotope of hydrogen called deuterium, which remains trapped in the Martian water cycle, while normal hydrogen is lost to space. The researchers found that water from the polar ice caps is highly enriched in deuterium, indicating that Mars has lost a tremendous quantity of water.
Now we know that Mars water is much more enriched than terrestrial ocean water in the heavy form of water, the deuterated form. Immediately, that permits us to estimate the amount of water Mars has lost since it was young.
The findings indicate that only 13% of an ancient ocean remains on the planet today, now stored in the polar ice caps. 87% of this ocean has been lost to space. This means that early Mars would have looked much different than it does today, with a significant portion of its surface covered by water.
So the really interesting question is, could it form a sea or an ocean? And indeed, it would. In the northern plains, which is a relatively flat region but depressed from the rest of the planet, it would form an ocean that was approximately 20% of the planet's surface area. And so that is a respectable ocean.
This ocean had a maximum depth of around 5,000 feet or around 1 mile deep. It's deep, not as deep as the deepest points of our oceans, but comparable to the average depth of the Mediterranean Sea.
By combining Martian topography with the new estimate for water loss, the researchers were able to simulate Mars's ancient ocean and its escape to space. As Mars lost its atmosphere over billions of years, it lost the pressure and heat needed to keep water liquid, causing the ocean to shrink and recede northward. The remaining water eventually condensed and froze over the north and south poles, giving Mars the ice caps that we see today. This new scenario means that Mars would have stayed wet for longer than previously thought, expanding its ancient habitability.
We now know that Mars was wet for a much longer time than we thought before. Curiosity shows it was wet for 1.5 billion years, already much longer than the period of time needed for life to develop on Earth. And now we see that Mars must have been wet for a period even longer.
It's fascinating that we can learn so much about 4.5 billion years ago when measurements are taken right now. And ultimately we can conclude this idea of an ocean covering 20% of the planet, which opens the idea of habitability and the evolution of life on the planet.